Okay, hello everybody. I'm Dr. Nizik. I'm the director here at New York Tech for the ETIC, the Entrepreneurship and Technology Innovation Center. And I'm a adjunct associate professor of computer science as well, where I teach courses in cybersecurity and data structures and things like that. So I'm going to be talking to you today specifically for today's intro session about Kali Linux. It's one of our, I believe, 10 sessions this year, maybe even this semester, on technologies that are industry level proprietary technologies that are extremely useful, and sometimes they're career paths in their own right. So we try to introduce you to them and how to get started. All right. So today, talking specifically about a product and a program called Kali Linux. For those of you who are in the cybersecurity world already, you're aware that there are tools that we use in cybersecurity to kind of do our jobs on a regular basis. Kali Linux is one of those tools that we're going to talk about today. I may jump around a lot on the slide deck I have because it's kind of a combination of Kali Linux plus an introduction to cybersecurity. So I may reference, for those of you who are new in some way, to computer science versus cybersecurity versus programming versus data analytics and things like that. I may, kind of jump around a little bit looser today. All right. So, Kali Linux is, for those of you who are unaware of Linux, Linux has distributions. They have flavors, versions of operating systems. So, Kali Linux is one distribution of Linux that is very, very specific and focused to something called pen testing or penetration testing, testing systems that are testing information systems to make sure that they are actually secure, right? And that things are in place. So today I'm going to talk to you theoretically and a couple of different examples, and give you some tools and give you some documentation to understand what Kali Linux is, where it lies in your overall career path and your kind of area of interest, and how we use it on a regular basis. All right, so the way we're going to do this, we're going to talk about some networking background and operating systems kind of basics. We're going to talk about the Kali operating system specifically, talk about some of the tools that Kali offers. We're going to talk about how to get Kali, acquiring it. I'm going to put a couple of caveats out there as well beforehand for you. We're going to talk about different ways that you can implement Kali and how you can use it in the field, right? And also we're going to talk about ethics and access, meaning how to use it is one thing, when to use it and why to use it, and should you use it is another thing, right? So there's a bit of wisdom here as well that you want to be aware of. There's also an entire legal framework around using Kali Linux tools that could cause you a lot of issues if you use them inappropriately. Violations of privacy, violations of security. Some of these things are not just misdemeanors, some of them are felonies, right? So you want to make sure that you're not just playing and causing issues for yourself down the road. So then we'll open up for a Q&A and a couple of different discussions on special interest groups and other things that are out there for you to grow and learn on. So, well, the first thing I'll do before I even get into that is to make sure that you're aware that Kali Linux is not a piece of software. It's an operating system, right? So if you decide to, finger quote install Kali Linux yourself, it's an operating system. So if you're on an Apple device, if you're on a Mac, a Windows desktop, if you're on your laptop and you decide to, again, install Kali, it's an operating system. So the process may actually, and most likely will actually replace your operating system, not install like on a, as a piece of software, right? It will replace your operating system, which will cause you all kinds of issues. So my caveat here is I'm not teaching you to install Kali. That's up to you. I'm teaching you all the tools that are involved in Kali and what Kali is and what role it plays, so that you are prepared if you do decide to go into the cybersecurity arena. So my first caveat is to make sure that you're aware that Kali just isn't a download and install of an app. It is an actual operating system. So when you decide to install it, you will be replacing the operating system on whatever system you're currently using. Second, whatever we talk about today and the tools that we talk about in Kali, and even demonstrate some of them that are available in Kali that we use all the time in industry, and especially in cyber, the improper usage of these things could actually break, several different U.S. and international laws. So you want to be extremely cautious of how you use them, right? So if you notice there, New York Penal Law, 156.10, computer trespass, computer tampering. These are felonies and misdemeanors that will be absolutely, potentially enforceable if you just decide to go into Starbucks and let me use Kali Linux to go see who's on Starbucks network, right? 100%. Even in your local neighborhood, if you decide to say, "Oh, I'm going to learn Kali and I'm going to do a pen test on my neighbor's system," 100% you're breaking the law, right? So unless you and it'll be viewed in any kind of complaint against you, it'll be viewed as breaking the law. So one thing that you want to consider here is that as you're learning about this stuff, you want to always have your own network, right? At home or a second network at home. You have your own devices on your public network, your Verizon network, your Cablevision network, but Optimum network. But setting up your own series of devices and switches and everything on a separate network is really the way to go. Right? And then everything you do is on that network. And that's totally legal, totally fine. But if you decide, as an example, to let me just kind of, while I'm in the doctor's office or while I'm at my friend's business, where he works, we're waiting to go out for a drink or something like that, while I'm here, I'm going to try to see what's going on at his company. 100% violation of both of these sections of law and totally enforceable, right? So it may seem innocuous, like it's not really that bad, but on the same note, it wouldn't be considered that way to any organization that you do. Right. Anyway, that's my caveat, and with that, we'll go into some kind of networking background. So, why do we need something like Kali Linux, a very specific operating system for penetration testing? Well, the reason is that we have networks, right? Computer security in the early days when we and unfortunately, I'm going to have to date myself here quite a bit, which is no way around that. But in the early days, before we even really had any kind of home computers or business computers, we had mainframes, and they were secure to a very large degree because you just used terminals to kind of attach to a mainframe computer. So the security was always on that physical computer. And even when you had individual computers entering the office, entering the homes, everything you did was in the person's house, behind a locked door, behind an office locked door, behind everything we had was fairly secure because somebody would have to physically get into your house and find the right disk and steal that disk. And, it was very little that could be done to really get data off machines. Once we started networking computers, once we started connecting computers in businesses together and then connecting them to a system, on a server, we have a server and workstation, like a client server, two-tier network, that increased the risks and the vulnerabilities on a network. Now, once we started giving outside access to the world through routers to basically connect everybody to other businesses and other homes and things like that, which has then ultimately led to the internet, everything changed. Everything changed, where now you had outside access to internal data. And that is why we have such a huge issue with cybersecurity today, is because all the things that we use and we ask for as customers to our banks and our networking companies and everything else, everything that we want to make it easier, right? We want to swipe to send money. We want to split the bill really easy, right? The things that we're asking for. Think about what we're asking for. We have to have an app that connects to our bank or actual checking account and actually approves with a swipe, one way or another, just to basically approve that money's going to be taken out of that account, right? Or we're going to have a credit card that has a $30,000 limit, and we're just going to type in numbers and swipe and send money off our credit card, right? It's crazy, but we keep asking for it, right? We want things, we want tools, we want products, and the banks and the financial organizations and everyone else keeps giving it to us to keep our business, right? Well, you don't have this ability to say Chase Manhattan or whatever. So you don't have this ability to provide me with these tools. So I'm going to go to Bank of New York or Bank of America, right? So they're competing for our business by giving us more and more tools and claiming they're secure, right? And that's fine, but they have to also do that security too. So this networking component here is really what led us to the point where we need tools, very specific tools and people and training and processes specifically to test if networks are truly secure and what vulnerabilities they might have, right? And when you start thinking about, all right, I'm a computer science person, I'm an IT person, I'm going to build a network. And you buy the routers, you buy the switches, you buy the workstations, you buy the laptops, you buy the tablets, you buy all this stuff and you connect it together and you run the wiring. That's networking. Okay. That is not cybersecurity. That is networking, and that is network design, and that is software design and configurations and all that. And that's needed, and that's a huge career, and it's wonderful, but that's not cybersecurity. Cybersecurity is the concept of saying, is that network configured properly to make sure that if somebody gets physically into the building, they can't get access to certain things? If somebody gets access from the outside, can they get into certain things in the network, right? So cybersecurity is not just the configuration of the network. It is understanding that network, how it's configured, and understanding the risks and vulnerabilities that that network has, and how to test them, and also how to fix them, right? So when you look at something like this, when you have this this local area network over here that connects to a switch, and then it connects to all these other workstations here, and you have a server, and you have a wireless router, and you have a smartphone, and you have a laptops, right? This area here with wireless, right? That is a vulnerability. How is that data being transmitted? Because everybody in the world can see that. This and these wired connections are vulnerabilities, because if this switch is an older switch with an older firmware that doesn't exactly perform some of the VLAN, virtual LAN capabilities the way it should, there's vulnerabilities in that exist on the older software and the older configurations that become a target for cybersecurity, cyber threats, right? So that are, and attackers that are connecting to your wired network from inside your building, from your HVAC system, right? That's at the outside systems that are outside your building. The heating and ventilation systems are a very high target and high priority because they're outside. Someone can get to them and attach to your internal network from the outside, and that's why they're targets, right? So attaching to the wireless network is one thing. It's easy. You can sit outside a building and attach to that, but those generally have security parameters that should be pretty strong, but may not be, right? So this concept of testing wireless networks, testing internal wired networks, figuring out what software is on these workstations that already has vulnerability. Don't forget, every one of these workstations has an operating system on it that may or may not have known vulnerabilities, right? That the software company has identified and put out patches for. If you have a Windows 10 operating system, or you have a Mac OS operating system that does not have the latest upgrades and patches, you have vulnerabilities that exist because those patches are supposed to be updated so that they fix their vulnerabilities, right? So that idea of an IT person in that organization going around and fixing all these things and making sure that the firmware on the router and the firewall and all that are updated. If that's not done, if somebody's kind of like taking it easy one week and they're not doing those things, those are open vulnerabilities, right? We need tools to test if all these different components on a network and on a system are truly in place, and are they known. That's called pen testing or penetration testing, right? The process of penetration testing is attaching to this network with a series of devices and software and communicating with the server to find out what is the server using as an operating system, what patch are they on, what what drivers are they using for their everything that would create some sort of a vulnerability to get access to this server and see what's on the server and possibly steal data from this. Everything that's on here is a vulnerability, so you need to make sure that it's up to date. Well, if you had to go through to 1,000 device network, tablets and laptops and servers and operating systems, and do each one of them, by the time you were done, you'd be 5 patches out of rotation. So you'd have to go back and start again, right? It would be a never-ending job, right? So the idea is we need systems and software and processes to basically make sure that when we attach to a network wirelessly or wired, we can go out and test all these things and see where does our network stand, right? Pen testing is the process of doing a penetration testing. Softwares like Wireshark and Nmap and John the Ripper for password cracking and testing, right? So those are things we use for pen testing to test the network to see if it has vulnerabilities. One place that we can get all those tools in one spot and all the updates to those tools and all the latest signatures of viruses, all the latest signatures of malware, all the latest and greatest, like to the minute. The only place that we can get all of those tools that we need to test wireless networks and wired networks and have them tested for the latest patches of all the latest software and all the latest known identification of signatures of viruses. The only place we can get that in one spot is Kali Linux. Kali Linux, by installing that software on a device that we can attach to someone's network and keeping it Kali Linux on the internet so that we can download all the regular patches that it needs to keep up to date with all those things, that's the only place we can do that, right? And that's why Kali Linux is a topic of discussion for interest. That's why Kali Linux is a tool that we use in very heavily in cybersecurity. And that's why Kali Linux exists as its own distribution version of Linux for those reasons, right? So hopefully that kind of lays the groundwork for our discussion today and kind of how it all goes together, right? So we'll talk a little bit about our standard model. We really have the TCP/IP model, which is really only 5 layers, but the OSI model, Open Systems Interconnectivity, has always been the normal model we talk about with networking. But keep in mind, when we send data over a network, we're talking about going from a physical layer into an application layer, and everything in between is what happens to those data frames, we call them, and packets, what happens to those along the way in each one, right? And what happens is that when I create a piece of top secret data, like a credit card number, an expiration date, and an auth code, I'm sending that to somebody and I'm encrypting it beforehand and I'm packaging it. But at every level of change in the packet before it actually gets to you and you open it in your application, we're doing something called encapsulating and decapsulating. We're encapsulating it and we're sending it and decapsulating it. Every level that we do this encapsulation, decapsulation along the way is what we need tools to look at to see, is somebody configured properly to protect the data at these levels, right? Data has 3 different states generally. It's in storage at rest, and then in transit and in processing, right? So in the processor, your computer is looking at data in the processor and processing it. It's vulnerable there because it's unencrypted. A processor can't process encrypted data. It can only process unencrypted data. So your processor is a target, and your in transit is a target, because in transit we can steal it easily. When you talk about data in transit, it's usually encrypted, hopefully encrypted, but it's easy to steal data in transit. Wi-Fi data is traveling through us at all points at all times. Wired data is being sent at all points at all times in these packets. We can steal the packets and look at them easily. The issue is that in the data of those packets, they're usually encrypted. Many types of encryption we can decrypt using Kali tools, of course. But if it's encrypted at a certain level, it's more difficult to decrypt. So we're looking at data being transported in any one of these layers, and when we get data that's in any one of these states, any one of these layers, and on the computer at rest, in transit, or in processing, we can test to see if that computer is available and ready to secure that data in the right way. And we can also see if somebody has any kind of malicious software on that machine to look at the data at the processing level and everything like that. Okay. So, and just to talk a little bit about cybersecurity in general, we have something called the CIA triad: confidentiality, integrity, and availability. Is the data that you're trying to protect, is it confidential in nature, right? Is it actually secure, so that you're only allowing certain people with the right permissions to see it, right? Integrity, is that data, that's the C. Integrity, is that data actually useful? Is it damaged? Is it destroyed? Is it, if somebody changes a date, removes all the slashes, can you still use that date? If they remove the last digit, is it really a date anymore? Because we don't know if it's 2024 or 2023, right? That last digit is removed. The integrity of the data is important. And availability, are the right people getting the data at the right time, which makes the data useful? If not, when somebody in your organization needs data and they can't get it, it's not useful anymore. So now the data. So you've got to keep all 3 CIA in balance when you make changes to the system, when you implement policies that are going to change the protection of that data. Now, what you're looking at now is something called the Cumber Cube, or the CNSS model. And in the Melikoglu cube, you're looking to apply changes in test systems with Kali Linux and pen testing. You're looking to test them to see, is the CIA triad in place, but also based on when you're sending data, when you're storing data, and when you're processing data, do these particular CIA components, right? Maybe when you're sending data, it's not secure at all, and all of them are at risk. Or maybe when you're storing data, you are, but you're sending data, you're not. So you have to, as a security expert, always manage the CIA triad along with the Melikoglu cube. Is this system actually secure in all aspects of the CIA triad? All right, so Kali Linux is an operating system. So we'll talk about operating systems in general. Whenever you talk about an operating system, you talk about Microsoft Windows, Apple, iOS, you talk about Android, Mac OS, Linux. Operating systems control the physical components of the computer, right? So in other words, the way the data is transmitted and stored, and the way it goes from the processor to random access memory to your RAM, and back and forth. The way it handles all that, the operating system takes care of the file system structure, the file structure alterations, how you're making new directories, how you're organizing your data. Everything there is the operating system, right? When you start thinking about things like Notepad's part of my operating system. No, Notepad is software that is on your operating system, right? So the operating system itself is the software that basically controls all the interaction, the printing, the scanning, the anything that's a peripheral, the keyboard entry, the mouse entry, like all that is your operating system. Everything else on your operating system that does something is a piece of software that your operating system might have incorporated, but the operating itself is really called the kernel, and the current kernel, and the kernel controls all of your access and controls to your hard drives and your optical drives and your USB drives, and like anything that the computer allows access to, the operating system is what controls that and secures it, right? So the operating system is a huge target for cyber attackers because they're looking to get access to your operating system components at the supervisor level, right? Now, your operating system, when it boots, is automatically at the supervisor level because it needs access to everything. So they're looking to get in there at that level so they can see data in all three states. They can see the data being transmitted. They can see the data being stored. They can see the data being processed. Now, data being stored can be encrypted if you've chosen to do that in certain folders. You can encrypt certain data. So that's not always the best way to go. But data in process can't be encrypted because the computer won't know how to do that. So they're really looking to watch what's going in and out of the processor. So you can write a piece of software that does that if you can get it to run at the operating system level. All right. So just keep in mind when we talk about Kali Linux, it's a version, a distribution of Linux that is actually an operating system, and that's how it works. Right. There are with different operating systems, there are different components that allow the operating system to work and allow you to interact with it. Remember, when you see like Windows and using a mouse, that's all GUI based, graphical user interface based, right? That's software designed to allow you to interact with the system easier. That's not always the case. Like a base level Linux system really is command line. You don't even have a user interface. So when you get something like I'm just looking around my desk here for something, but if you got something that was an electronic component and did some amazing things and blinked lights on and off and control things, and it was like this big, and it was just a simple EEPROM chip that's programmable. That EEPROM chip might have a version, a really base core, it's called Core, C-O-R-E, core version of Linux on it, an operating system, right? It's got no Windows interactive interface on it, right? It's just, but it's still an operating system, right? So just keep in mind there's different components to an operating system that you may or may not be familiar with, right? So one is the bootloader, right? The software that manages the boot process, right? When the computer comes up, it's checking to see what it has plugged into it, right? What it can do. That's your bootloader. The kernel is the one piece of the whole that is actually called Linux, right? In this case. So it's the core of the system, manages the CPU, the memory, the peripheral devices. Once it boots up, the kernel actually is what's operating and doing any kind of logical analysis to say, oh, somebody wants to send something to the print. The print is located on USB, whatever the location is, whatever it is. So the kernel is actually doing all that logical components to see what does somebody want to do, what are they asking it to do, and how does it do it, right? The init system is a subsystem that bootstraps the user space, charged with controlling daemons. Daemons are the background services running and scheduling things and firing off things as background services, right? So when you boot up Windows, you have daemons in the background, which are Windows services that run, that control communications to other devices, and they're all kinds of things. So basically, you have these different components of an operating system that are required to be considered an operating system, but in its essence, Kali Linux in this case is an operating system that will control your computer, but also will have tons of software included with it to do pen testing and penetration testing. Right? Just to put it into perspective, Kali Linux is a version of Linux, distribution of Linux, in a long line of different versions, right? Different distributions. Kali Linux is a specific distribution of Linux, along with something like Ubuntu and Debian. It's a Debian-based operating system. Solus, Zorin, Fedora, Deepin. So all these particular versions of Linux exist for different reasons, right? One is meant to be a real user-friendly version. One is meant to be a core lightweight version. One is meant to be so. Linux is popular because it's publicly supported by a whole bunch of different volunteers. But on the same note, the licensing is free. So if you download Linux and you want to create your own version of it, you don't really have to pay anybody. That's why it's so popular. Okay, so in this demo, in this version, we're going to talk about the Kali operating system. So what you'll see, there's a company that manages it called Offensive Security. So that particular organization basically keeps track of all the different virus signatures, all the different malicious software updates, everything else, and basically make sure that all of their software that they're including in their Kali system is always looking at the latest kind of vulnerabilities that are out there. When you use Kali, the Kali does have a graphical user interface. So as soon as you install Kali on some device that you want to have, maybe you've got an old computer lying around, and maybe you've got an old laptop or something you want to put it on, that's fine. And the way you navigate Kali is pretty easy to load up different pieces of software. If you've never used Linux before, it's a little bit of an adjustment. It's not Windows-based in nature. It's not Apple. So they try their best to basically make things very usable, but there are times when you're kind of like, what am I supposed to do here? So it's still very useful, but on the same note, there is a learning curve for it. So Kali does have its own security once you log in. The reason Kali is so specific to cybersecurity is that you would never install the Kali operating system to basically, I don't know, control like a Raspberry Pi or something, or control some other device for an alarm system or something. It's just not. It is Linux. It is ability to do what other Linux systems do, but there's so many things on Kali that make it almost dangerous to in a lot of ways. The things that the system is programmed in ability to do, you could cause real damage on certain systems based on the way you run certain tools, right? But you'll see in the Kali kind of breakdown, they categorize their tools, right? They categorize into information gathering tools, vulnerability analysis tools, web application analysis, database assessment, okay? In a network, if you had it before, you have database servers, you have file servers, you have workstations, you have, right? If you want to test if your database, systems, your Microsoft SQL Server, your Oracle, your MySQL, your other types of databases that you have out there. If you want to test if they're secure, you can use the database assessment tools to do that, right? You can look at password attacks, wireless attacks, reverse engineering. You could try and program these things and configure these things in a way to test your system to see if it's vulnerable to password attacks, if it's vulnerable to wireless attacks. Now, what that does a lot of times is cause issues on your system that were never there before, because the Kali system and the software is actually making changes, just attempting to make changes. If you do have a vulnerability, it's quite possible, if you don't run the tool the right way, it's quite possible you could do damage to the system, because Kali Linux is doing a pen test saying, let me try this, let me see if I can change this, and then that will give me a backdoor access into this. And those things are actually happening, and now you've brought a perfectly good system down and running. I'll give you a practical example. Companies that do pen testing, penetration testing as a service, that are using Kali as one of their core tool sets, they have to be bonded by an insurance company. They have to make sure that they are legally allowed, permitted to do the pen test, but also that if they do damage, that they have to now call in some company to do $40,000 worth of repair work, which is probably like a day and a half, to be honest with you. It could be a lot more than that. The average cyber attack recovery time is like 50-something days now, and the average cost is like $4.5 million, right? So if you took all the cyber attacks off around the globe that are at least reported and tracked, and you broke them down and averaged them out from the large organizations to the smallest, mom and pop ice cream store, your average cost of recovery is $4.5 million. So, even if you even if you perform some sort of a cyber attack for fun to see, okay, I wonder how this works. That's why the crimes are there. That's why the laws are there. They want to make sure that that money is recoverable in some way. Okay, so this is a very serious topic and a very serious tool that can give information and feedback that gives you an incredibly high level of security based on the changes you make, but it could also do a lot of damage. So you want to be extremely careful. So the tool categories, we want to just kind of focus here. These are information gathering, vulnerability analysis, wireless attack, web applications, exploitation tools, stress testing, forensic tools, sniffing and spoofing, password attacks, maintaining access, and reverse engineering, and reporting tools and hardware hacking. So the tools that they give you, there's 226 tools or something like that, but that does grow, but overall the main ones are the important ones that we use all the time. But they're categorized in these areas so that when you're looking to do something very specific in your organization, to say, look at wireless, look at your web server, right? Look at the web applications you have and see what they are. These tools are geared to do that. When you start looking at the actual tools and the tool listings that they provide you with, like AirCrack, AirCrack is used to do all kinds of wireless simulation attacks on your individual wireless routers, right, and your wireless system in general. So even if you have wireless routers that do connect to kind of a centralized hub for a geographical area, it'll do analysis on what type of encryption you're using, on the key that you use and the password that you use for it. It'll look at any kind of histories of attacks that have happened or that might be going on at the time. But each one of these tools is a very specific need. Some are really broad, like the big ones, like Wireshark and Metasploit, right? Those big tools, Burp Suite, right? Those are big, broad tools that do, and they're kind of expensive, to be honest with you. Some of them are purchased, or some of them have free versions, but some of them are console-based, simple tools that just run and do a really good job of what they do, but they have a very specific purpose. I've created for everybody a PDF that is, Kali produces web-based content, and you click on it and you go into each one. That's great. I've taken the time over the years to kind of create a single document so that when you look at, say, the AMAP package as an example, it gives you the tools itself, the operations, the parameters of how to use the actual, right? How to use the actual. This is the console command to use it, but these are all the actual parameters that you could use with it, right? So this particular text document provides you every one of those tools. I think it's very, very long, but it provides you with every one of those tools in one sheet. So again, I'm kind of an old school paper guy. I like to have like a manual to go up stuff in. But even if you use the PDF, like on your phone or something, to say, I wonder what this does, it's just a little easier than going to, you go to the Kali Linux website, you go to tools, you go to certain, it might be just easier for you to kind of search the PDF on your phone. So I've created that for you. I'm not exactly sure yet. I'll do it after we stop recording, but how to share that with you. I think I could share it through Zoom and you could download it, but I'm going to do that after I stop recording so I don't waste time. Back to our presentation, right? Our discussion. So how do you get Kali, right? So what do you do? So basically, there's a Kali.org website. You basically figure out which, okay, I was going to try to scroll in. You figure out which version of Kali that you need to install. Sometimes it's the beta version. It's like the latest version, but it might actually have some issues with it. So you don't always want to use that version. There's usually something called the latest stable version, and you can download that. And once you download it, you install it. Now, remember, this is an operating system. Once you go through this process, if it does have an automatic installer to it where it's going to install, you are going to change your operating system. So I'm not suggesting you do this, not recommending you do this. I'm simply showing you where to download it from. Okay, that's up to you how you do it. Now, usually what you download is something called an image, right? So the image itself is one single file, and it's not its own installer, but you never know. They might have changed things or changed them where it's just an installer to do like a piece of software. But usually what you do is you have to actually have to create a bootable device, like a USB or something like that. And then if that image is also on that bootable device will give you an option to install that image on your hard drive or actually boot up off like a USB drive. That's one of the things, one of my favorite ways to do it. So the way to implement Kali and use it without really having to do too much changes or damage to anything that you're currently using is what you do is you create a bootable USB drive, right? So you take one of your USB drives here, and you create a bootable USB drive, and then you place the image on there, and it'll boot off your computer will actually boot off the USB drive if you hit F2 or whatever it is, F12 or whatever it is, and choose the boot drive. And then it'll just boot into Kali off of the USB. So you'll still have all your access, you'll have internet access. It's pretty cool, actually. It sees your network card and everything. So it's one of my favorite ways to do it because you're not really changing anything on your computer, and you kind of have this little small little device that you just kind of boot off of, and then you're using that system on the network. So one of the ways to create that is the Rufus.ie. So if we, I'll see if I can bring that up for you real quick. So Rufus is a website that you can download a little piece of software, and what you do is you just kind of tell it what image you want, and you tell it where to load it. Like here's where you would pick your C drive, but you could pick your USB drive, and then that USB drive will get written with the Kali image. It'll get written, and then when you boot off that C drive, it'll actually load up Kali on the machine that you're using. So it'll keep your Windows drive, it'll keep your Linux drive, whatever you currently have running there. It won't touch that. It'll just make the bootable USB drive ready to load with Kali. And then when you take the USB drive out, you reboot your machine, it's back into Windows, whatever it is. So I do like that version. I'm still not recommending even that. I'm just saying that that is one way that you could get Kali to operate as well. Okay. So one thing I just put up here, the server-based, workstation-based, or USB-based, so you can actually take one of your servers on your network and make it a Kali Linux machine that's just always running and always there. You can even automate some stuff to happen in Kali that is scheduled to happen, so you can fire off using the Kali tools. You can fire off those tools to run with the Kali scheduler. You can basically have them do a network analysis and things like that. You run on a workstation that's just installed there and boot up off of that. It's called a dual boot. You can boot into Windows, boot into another version of Linux or whatever. You can boot into Kali Linux, and then you reboot your machine. It gives you an option. You choose a dual boot option, and then USB version, which I just told you about, to create a bootable USB thumb drive, and then you just boot off of that. All right. Okay, so I'm going to show you some of the key tools that Kali offers you in scanning packets and mapping networks and things like that that we use all the time, and then discuss some of the others that are more not dangerous, but they're much more care has to be taken the way you run them and what you run them on. But first, before I do that, we're just going to focus on on some principles of ethical hacking. Again, these are kind of the 10 commandments that we use. I'm not going to go through them all, but I do want you to know that they do exist. Why do they exist? They exist because you may be doing something for your career. You may be doing something for your own understanding or education, but you're also possibly and potentially causing others, right, damage, right? So if you're on a network and you at work and you're like, oh, look, Bob, Mary, and Jane all have these files that they share. There's a point where you're ethically, required to make the decision to say you don't do something just because you can, right? You don't do something just because you have the ability to do it, right? There's an ethical version of control in here. And you'll see, like, I respect others and not use information to harm a person. I will be honest, ethical, and moral, to true to my word while using my technical skills, right? And, I'm just jumping around here, but I will work to reach my full potential while applying hacking techniques, right? So you're going to work to reach your true potential as a cyber analyst using your techniques, right? You're not going to use them to give yourself some advantage over someone else, or give yourself some knowledge that someone else doesn't have that you've acquired unethically, right? That's the kind of 10 commandments here that, again, once you learn how to do something, once you know that there's tools to do something, once you have that ability, you have to decide when to use it so that you're not hurting others. All right, so we'll get into the Q&A in a little bit, but let me just bring up some things that you may or may not know are out there. So the first thing is that whenever we deal with any kind of computers and computer networking, we're always dealing with packets. And there's a program called Wireshark, very popular. It's part of the Kali Linux operating system in the Pentest package, but it's probably one of, if not the most used tools in network administration and also in cybersecurity, because what it does is it captures all the packets that we see in our TCP/IP model and our OSI model. The packets that are flying through our airwaves, right? The wireless packets, the packets that are flowing through our wired networks, right? You'll see network wires all the time that are plugged into the wall and into the back of the computers, right? Those packets represent all the data that is at risk, right? The data that people are working so hard to try to steal and commercialize and somehow turn into cash for themselves, that data is what's at risk. So how do we use something like Wireshark as a tool to capture packets to see what we're doing? So to give you an idea of how this works, you would basically, just like any other piece of software, you would just double click and load Wireshark. Again, you have to install it. Wireshark.org, it's a free download. Everyone uses it for all kinds of reasons. Very, very popular and kind of the industry standard. And what we do is we go to capture packets. And when we start capturing, what we do is we choose the interface and we give the interface permissions to access our network card. Now, our network card is what's sending data, but when we start capturing data, that data is now being captured and stored temporarily in the Wireshark program in little small databases and everything. And what happens is that we start to see things come in that are possible concerns to us or possible things we want to take a look at. And what happens is that, I'm just going to stop this so we don't collect too much data, but what happens is that when we actually select a packet, when we actually capture a packet, this is actually a packet that could be being sent from my machine or someone else's machine to my machine or whatever it might be. But that packet came from a source, some IP address on our network, went to a source, right, which is the destination IP address here. We know that it was transport layer security, which is basically the 443 layer. And we see that the length of the packet was 92 bytes, right? So now what we can do is we can double click on that packet and start to look at the frame information, the interface information, where did it come from? This is the MAC address of the machine that sent it, right? If we have a concern on our network about an enormous amount of packets being sent during times of the day that our network seems to slow down, we may want to look at that particular device. That's one network card on our network that we think is causing all these issues. And maybe we have an observation we make or a suspicion, and we then we use Wireshark to capture packets only for that MAC address, only for that protocol, and only for that time of the day. And then we can start to see, yeah, the data that this machine, in the back office of the packaging room, right, generates 500 times more traffic between 1 and 2 in the afternoon, right, than any other machine in our building. Okay, so that's why our network slows down around lunchtime. Now we know there's a certain packets are being sent, certain type of packets, and now we know that that MAC address is definitely the culprit doing it, right? So we used Wireshark to figure that out. Now, when we go back to the room, we discover a deeper scan. We discover that there's software on that machine that is malicious in nature, and that is triggered to fire off between 2 hours of the day, right? So somebody got a virus, somebody used a USB with a virus, something happened, but that particular machine is right. So again, I could sit at my desktop in the office and scan any computer or all computers on my network to see who's sending traffic and what are the ratios of traffic, right? So Wireshark is a piece of software that's part of Kali Linux that we use, and we can use the analyze feature to kind of create filters, to only look at data for certain IP addresses, only look at data for certain types of types of programs, only for certain ports, right? We can configure Wireshark to collect the data that we find suspicious, right? And then analyze that data closely, see, oh, there wasn't a problem. It just happens to be a piece of software that gets very busy around lunchtime, or it's definitely something designed to fire off at that time. So, so Wireshark is one of the packet capture is what we're doing. Wireshark is one of the tools that's part of the Kali Linux operating system that does that, right? Second thing is something called Nmap, and what happens with computer networks is that we have all kinds of devices that are supposed to be on our network because we went there and installed them on it. We plugged them in, we connected them to Wi-Fi, we gave users access to them. They're supposed to be there, but sometimes there's stuff there that shouldn't be, right? And what does that mean? Somebody brought in a little Bluetooth speaker, somebody brought in that has Wi-Fi on it, somebody brought in their own desktop from home. There's something called BYOD, bring your own device, and it's a policy that companies say, look, I don't want to spend all this money on equipment, so I'm going to have a BYOD policy so that everyone can bring in their own device, but they're going to have limited access to what they can do, right? So somebody brought in a device that they shouldn't have because we have no BYOD policy. Somebody brought in a device, and by the way, if somebody brings in a device and then attaches it, their Fitbit or their whatever, to the Wi-Fi, usually the Wi-Fi is secured so that's allowing public access. They want people to come in publicly and use it, right? That's the idea of it. So usually that's okay. But if somebody brings in their laptop and plugs it into the wired network, that wired network is not secured the way the wireless network would be, right? So, right, you have a laptop or a device or some sort of a device with an RJ45 connector in the back, and they plug it because they want high speed. They don't want the slow speed 802.11 speed, right? Even if it's a higher transfer rate. They want the top. They want a gigabit network too, so they plug their laptop into the hardwired network. Now that device with no, without appropriate virus scan, without appropriate malware detection, right? That device is on your network and it shouldn't be, right? So how do you find that out? And the way we do that is with network mapping, right? So and what you'll see is that with network mapping, this is something called ZenMap, which is a Windows version of Nmap. But if you were to go to a console-based command line, we can also do Nmap, right? So Nmap will give us a whole bunch of different parameters that we can run on our network, while ZenMap gives us a little bit of a easier graphical user interface and will also give us the right code to use in Nmap, right? So it's a cool tool to learn from. So I suggest learning from ZenMap as well as Nmap, because Nmap will give you a little bit of a learning curve. So to give you an idea of kind of what I'm talking about, so every computer has a IP address, and that IP address has a default gateway, which is usually the router the network gets connected to. Okay, so what I can do is I can actually do a full scan on the IP address of the machine I'm on, and what may happen, what should happen, is that if I run a full scan, right, on this IP address, and I run an intent scan, right? So in other words, we're doing intent scan plus TCP ports, right? So we're doing intent scan on every TCP port that's being run. This is the actual command that can be typed into the console mode, which is very useful because you don't always have your GUI interface you might only have command line interface if you're using certain systems. So it's very useful to use, but again, this is an easy way to teach it in a session like this, and also gives you the alternative console mode. So if we run this scan here, and I click the scan button here, it's gonna ask for permission to do it, which is fine. But it's now gonna run an intent scan on my network based on that IP address, and it's going to tell me everything that's running on my ports, right? So what we should see as it goes through this, hopefully I get a little bit more back to this. It's running in 10 seconds, so it'll take a little bit longer. But what it does is it goes out on your network and picks any machine or any range of machines or your entire network. Your entire network would probably take hours, but let's say you're just concerned about, I don't know, a range of IP addresses. All your servers are labeled 192.168.1.1 to 192.168.5. So you do a range of servers, 1 to 5. I want to do an intense scan on all my servers and see what those servers are running on all their ports, right? Maybe you want to see all the devices on your network just to get an idea of who's on your network. And then those scans turn back the type of operating system it's using. It turns back the latest patch that it's using, right? So you can actually use all of these different tools with scanning your network to give back all the components of your network that's there, but also what each one of them is using, right? And that starts telling you to be like, oh, this one had this particular system has all these ports running, right? So this particular 65301, right? PC Anywhere for some reason. I haven't seen that in years, but for some reason that's actually running, which is a vulnerability that should be looked at to see, are we getting any kind of risk from those ports, right? So this is an intense scan on a particular server or PC in this case, and it goes through and it finds every single thing that's being run at this level. So I think I did a little bit too much because it's also not scrolling for me. But so these different things that you'll see, right? Direct play server, whatever, it winds up telling you these are all the ports with all the software and everything that's running on it. And you may discover things using Nmap on your whole network, on every machine you have, on one machine, on just 2 machines, on a range of machines, however you decide to use Nmap. When you map your network, instead of going to each machine, each device, and trying to do all this work on it, you run Nmap and it goes out and does its thing and comes back with any alerts. Now, not part of Kali Linux, but I do want to point this out to you for any of you considering cybersecurity as a career, right? So all these tools, what you'll start to see is that all these tools are able to kind of save out all of your results into files, external files, where all the data of the results of these tools are out there. Now, what you'll see a lot in jobs is something called scripting. And whenever we talk about scripting, it's like not programming where it's going to compile it into some sort of executable. It's just a way to do a lot of things one step at a time. Right. So Python scripting and JavaScript scripting, right? So you want these tools to go out and run a lot of these programs through console mode, but also automatically save the text file, the output file, right? Why? Because we want to import in these output files into a Python, project, program, and basically say, look, parse out this data where I just ran this intense scan of my entire network. Now you want to find everything about this IP address, everything that you consider suspicious. Once the data exists in the exports of these tools, you can't really reproduce that. They just did such a good job of it. Why would you bother? But what you can do is you may have a different way of looking at your network that is very unique, that gives you a lot of feedback to tell you if something's going on in your network. Oh, that every time the UPS guy comes back in, we seem to have a slowdown. We want to see if his device is attaching and causing us issues. So you could write a Python program that looks at the data that's exported after the UPS guy leaves and then parses it and processes it and says, yeah, yes, by the way, you have 150 times as many packets as you should, only, between the hours of whatever after the UPS guy leaves, right? So maybe his device is causing some other traffic or something like that. So you have the ability to do that. So just keep in mind, when you're looking for jobs, you're looking to move into cybersecurity, scripting and programming is really important. Not so much that you're building software to release to people. You're building software that you want people to, you're building software that's basically bringing in all the output from other programs, and you're looking at it in a very unique way. Machine learning is a big deal right now because machine learning allows you to take data in from large data sets from analyses that you did, and then it allows you to kind of take those results and apply to some model that you created and say, yeah, you know what? Normally we're okay, but we've got a very, very high hit, percentage rate of accuracy in this one. And that means that this model that we built to identify some sort of anomaly that's threatening in nature, this model that we created, when we ran today's data through that model, we had a very high percentage that this was going on, right? So machine learning algorithms as well are used off of current data captures. Right? So anyway, so I'm gonna finish up by just kind of having this discussion with you. The one tool that you want to be aware of that we don't show for a number of reasons is Metasploit. So Metasploit is a tool that you can use that actually identifies it's part of Kali Linux tool set and the operating system, but it actually identifies on your network all the vulnerabilities that are out there. I mean, it's an operating system with this old version of whatever the software is or whatever it might be. And the good guys use it to find flaws in their system and fix them. The bad guys use it to say, you've got a flaw in your system, I'm going to use that to perform my ransomware attack, right? So anyway, this is kind of the big introduction to Kali Linux as an operating system, all the things it does, how it works, where it lies in the big picture of things. And it's one of the tools that in cybersecurity as a profession is used, every day in some way or another. Okay. So with that, I'm going to stop the recording portion of the intro session. I'll open up for any questions after that, and I hope you enjoyed the session.